folks, Quillyteen here, and welcome to another episode in our ongoing series of mini modules, mini tutorials on making a web server application that a Unity game can interact with. And in today's video, we are going to be looking at adding database support to our web application. Now, if you've never worked in a database, basically what a database is, we're just a way for us to store some data and then retrieve it later on. And the thing is, there's no reason we can't just do something like write to a text file, right? Our Node application can create a regular file, can be a text file, can write out lines like, let's say, it's a text file full of usernames. So it's username, comma, password, comma, email address, right? And we just have this one text file that's got all these things in it. And when someone logs in, we just open up that text file, search for their username, and do that. The issue is that that's quite cumbersome, and it's also not going to be very fast as the file expands, because we have to search through the entire file to find the one person. If we've got 1 million users and they're the millionth user, we've got to sort through 999,999 lines before we find that one. So then it's like, well, how do we get that search better? Through indexing and various things like that. Well, that's where a database comes in, and that's really all it is. A database is just a system where internally it's saving the data in some sort of format, but it's got various indexes and things in there to make it able to very quickly and rapidly look up entries that have been stored in. So what we're going to do is we are going to expand a little bit on our structure of our little test application here, get it a little bit closer to what the real application might look like, but also go ahead and do the installation. So we're going to be working with MongoDB. MongoDB is a database server that is very common in the Node community. There's lots of different database products, and here's the thing. For me, I'm used to SQL SQL databases. When I had my day job as a web application developer, that's what I worked in. I did a lot of work with MySQL, PostgreSQL, even Microsoft SQL Server. In fact, my first job was using an SQL interface that I was actually just backed by an Access database, which was not very good. And one of the things I did at that job is migrate it from the Access database to a proper Microsoft SQL Server setup. So that's my experience. MongoDB, however, is a NoSQL database. So discussing the differences between them is a little bit beyond the scope of this tutorial, and certainly beyond the scope of my skills as well. But it's a little bit softer. It's a little bit more relaxed. One of the things typical, hardcore database things have you do is define very rigid tables for storing the data in. This is going to be a little different. We're still going to be defining models/schemas here to sort of structure the data, but it's nowhere near the same level of setup. Now, the first thing you're going to have to do, though, is you are going to have to install MongoDB on your computer. MongoDB runs as a server application of its own, and the way it works is our Node.JS web application will connect to this server using just network operations, and we'll use that network connection to send requests and queries to the database, and MongoDB will return the information that we want in response to that. You can run it on the cloud. In fact, when you were to deploy this as a real application, most likely you will be using something like the MongoDB Atlas system over here to just run MongoDB over in the cloud, and as opposed to your own computer, or maybe you'll have your own server on, you'll have a DigitalOcean setup or something like that, and it'll run there. There's lots of different ways to do it. It is available for Mac, Windows, Linux, all the things, and you can just download it. You're going to want the community server over here as opposed to the enterprise one, and you've got your downloads. You can just choose your format, download it, and install it. On Windows, when you install this, it will also give you the option of installing the MongoDB Compass. I suspect something similar will likely happen on the Mac. I've never installed it on the Mac. On Linux, you will have to go and probably install it separately as a two-step process, and the install on Linux is slightly different. Usually, for me, when I installed it on my Ubuntu build earlier this week, what I did is I downloaded a .deb file and installed it from there after doing a couple of shenanigans. So depending on your format or on your system, you may have to install it in slightly different ways. So the MongoDB server itself, this is the actual database application, but then you also have the ability of having these front ends. So the MongoDB Compass is a very popular front end to allow you to interact with the database. This is not actually required, but this just gives you a really good way to see the status of your database, look at your data, manually make changes, and it's really good for development. It's worth noting that there is, oh, it's not on this page. Oh, that's interesting. There is also a MongoDB plugin for Visual Studio Code that basically does the same thing. I've decided to go down the Compass route, which I have installed over here, because this is the thing that is going to be referenced the most. I'm seeing in other tutorials and books and things you can get. And so by doing this, we will follow as much as possible the standard pattern that if you are looking for other tutorials, you'll see other references to people using Compass over here. And yeah, it's just a graphical front end for you to connect to your database with. So once you have MongoDB installed and running on your computer and you've got Compass installed, you can check and make sure that it's working by connecting. You can enter a specific connection string to connect to an arbitrary MongoDB server anywhere on the internet, but if you just hit connect, it should just correctly connect to MongoDB that's running on your local host using the defaults. If you haven't made any changes from a default install, it should just connect, and there we go. I am connected to the database that is running on my own computer over here. If we were running this on one of the MongoDB Atlas, somewhere in the cloud, you would have a connection string there that you can use to connect to that version of it. But we're just going to go ahead and use the local host version over here for testing, because it's going to be really easy for us to do that. So we're going to pop back over into our code. Now, right now, we have everything running in this one server.js file, which is absolutely not going to be the case going forward. We are going to break this up into a few different subcategories. And we're going to start right now. We are going to make a database test script over here to play with. So we're going to leave this the server.js code alone. I'm just going to make a new file over here. I'm just going to call it something like dbtest.js over here. Okay, so the first thing we're going to do is include or require the Mongoose module. One thing I want to note, we are going to be switching away from using var to declare variables in the future. You may have seen in the first video when I started typing, there was a moment of hesitation of, do I want to have a discussion about const and let right now? No, I decided to just leave it for the future so that we can have, we can talk about the reasons why we're going to want to use those, and basically never use var to declare our variables. That is something we're going to talk about. We'll do some sort of best practices and coding standards kind of video. Probably will also be installing a linter at that point to make sure our code is following best practices. So for now, yes, absolutely you should be defining more things with const, and the rest of things should probably be declared with let. We'll get to that later on. So I just want to acknowledge the people who were wondering about that, because you are 100% correct. Just trying to keep it simple here. And if you don't know what we're talking about, hey, don't worry about it. We'll get to it a little bit later. Okay, so we're going to be pulling in that module. So same sort of thing we've done before, where we require mongoose, like that, like that, like that. Excellent. And then we're going to connect to our database. So we're just going to connect mongoose.connect. And to connect to the database, it is going to need a connection string, a URL string, well, URI over here, but it needs a connection string because, again, MongoDB is just running on a server somewhere. So just like a web browser needs an address, http:// in the location bar to know where to go, the Mongoose module needs the exact same information so it knows what MongoDB server to connect to. In this case, it is the MongoDB server that is running on our own local computer. So the address will be localhost. You could also put in the actual IP address of 127.0.0.1. That's your loopback address. That always points to your own computer. If we were running this, on another server or on a cloud server somewhere, they would provide us with a connection string that we use here. The last thing we do need still in this connection string, however, is we do need the name of the database we're going to be connecting to, which is just going to be our test DB. Did I invert these names? I had to scratch a recording and restart. I don't know if I called this test DB or DB test originally. But for our database, I'm going to call our database test DB just because that seems pretty reasonable. Now, we could stop here. If we did this, we would get a deprecation warning from MongoDB when we ran the code, which is fine. The thing is, when MongoDB originally came out, it had certain types of functions with certain structures and certain formats, and the Mongoose module was built to use those MongoDB functions with that kind of thing. But since then, MongoDB has continued to progress forward, and they've changed several things about the code. Some functions they no longer use, or they want to use in a different way because it's going to be better. And they even have newer, more advanced connection strings that can hold better data in a smarter way. However, to maintain backwards compatibility with any application that had been built previously using MongoDB and /Mongoose, a lot of the old stuff is still there, but it's tagged as deprecated, and you will get warnings when you use them that, hey, this isn't the correct way to do it, and it might go away these days. And one of the first things we'll encounter with that is with our connection string. The format of the connection string did get changed at a certain point, so we are going to specify that we are going to use the new URL parser true over here. This, first of all, if our connection string actually uses the new format, this is kind of going to have to be required. And then the other thing is this will get rid of that deprecated warning. We're actually going to get another deprecation warning nonetheless when we connect over here. I'm gonna leave that in so we can actually see it in action. And then we'll look at how to eliminate that warning to let us know that we're doing something out of date. So we're still going to get a deprecation warning, but in a second. So that connects us to the database. If this database does not exist, it will get created instantly. This is something that for me is quite nice. When I used to have my day job as a web developer and we'd be developing a new application, I would have to explicitly add some sort of like initialization code, either in some sort of setup script or when the application started up, and it would have to look to see, hey, does the database exist? Yes, no, oh, it doesn't, so I better go ahead and create the database. Then I have to go and manually and explicitly create every table in the database ahead of time. One of the nice things that we're going to have here is things are going to be created automatically the first time we try to access it. Internally, MongoDB will be like, oh, we're trying to access something that doesn't exist. Oh, that's okay. We'll just create it right now. So we don't actually have to do an explicit configuration setup script, which is really, really, really nice. Okay, so now that we've connected the database, what we're going to do is we're going to define our first model/schema/connection. Even though MongoDB has a fairly kind of just very loosey-goosey, things get made on the fly, we still want to define a certain amount of structure about our documents. So the structure of our database is such that our database will contain collections, and the collections will contain documents. Now, to me, I think of it as the database contains tables, and each table contains rows or records or entries, depending on what you want to use. But they mean the same thing. In our database, we will have a collection called maybe users, and another collection for, I don't know, cat pictures. I'm not sure what the collections would be. Inside of each one of those collections will be a series of documents that will theoretically have the same structure. MongoDB is actually pretty loose about that. You can have documents with different structures within the same collection. You probably don't want to just be crazy about it. What most likely is going to happen in practice in terms of a collection having documents that have a slightly different structure is if the structure, the structure of your object that you're trying to save changes slightly. Like, for example, maybe originally, let's say we're having a users table, right? And you have a field for name, right? What is your name as opposed to your username? What is your name? John Smith. And then later on you decide, you know what? We should have separate fields for first name versus last name. So then you'll have some documents in there that have just, name John Smith, and then some others that have first name John, last name Smith. Insert discussion here about how naming conventions vary dramatically across the entire world, and the first name versus last name thing is probably a trap, but that's a whole other thing. There's a support you can have. What you want to use in those situations is a sort of like little versioning number in your documents, so that if you load up a document, check to see if it's got like version number 2 in it, and if so, well then you're going to have to send it to a different function to operate your document or whatever. Anyway, I digress. It's not particularly related to what we're doing here. Anyway, we are though here to make a schema. So again, this is going to be a const thing, but can do this. So we're going to just grab a shortcut basically to mongoose.schema over here. This is just saving us a little bit of typing going forward if we're making a lot of schema. Everything we're about to do with schema, we could just use by referring to mongoose.schema every time, but it's going to save us a little bit of typing. So we're going to create, let's make a little chat thing, okay? Our whole goal here, we're just going to have Unity. It's going to send us some sort of string that we're going to save in the database, and then we'll display all the strings. That's basically what a chatting system is. So we're going to create a chat line, like a line of chat schema over here, and it's going to be a new schema. And again, over here I could say new mongoose.schema, but it's slightly less typing and it looks a little bit better. And so what we're going to do here is we're just defining the structure of what the chat line documents will look like. And I think all we're going to have is when you're chatting, it has like a username, which is a string. And I guess it has the actual like line of text, which is also a string. We could have other things in here. We might want to store a timestamp of when it came in. I don't know what else, but for now it's going to be okay. I suppose if this chatting system would have multiple channels, then you'd have to store what channel this is intended for, all those sorts of things. But for here, for our purposes, to make this extremely simple little example, we're just going to store a username and a chat line. So the schema here defines the structure, the way these records are going to look. And then we have to do one more thing, which is from here, we are going to create the model. It's basically what we're doing here is we're linking the schema to a specific collection. This is going to make a little bit more sense in a second, I think. For now, let's just assume we have to do one more step where we go mongoose.model. And then we're going to put in the name of our collection. The name of our collection at this point is going to be chatline. And then we have to pass it the schema, which is our chatline schema. Done. Okay. Now, later on, we are going to be doing a bunch of this work in specific modules to handle this. We are going to have a folder probably called model, I suspect. We're going to be doing this work. At this point, we would be doing something like module.exports, and we would be turning chatline like this. And later on, in some other piece of code, we would be doing something like require model/chatline, and we would be importing that into some other code somewhere. We don't need to do that now because we are just doing this with a single dummy file that doesn't do anything else. No problem, no worries. So now what we're going to do is let's create our first record. Okay, we have our reference to our model over here. So all we're going to do is chatline.create. Now, there's a bunch of different things we can do here. We can, well, I mean, first of all, even just with create, I mean, there's create indexes, for example. There's create collection. We don't actually have to explicitly create the collection. The first time we try to add a record to our chatline collection, it's going to create the collection for us. So we don't have to worry about doing that explicitly, which is really nice. So it's just a function. It is going to take in some properties, which is going to be our username. We are going to say, so Quill18 is doing the chatting right now. And then it's the actual line of chat. We're going to say, hello, chatting world. Boom, like that. So this is actually just going to work as is. But what we'll do is we will put in a second bit over here. Chatline sends us back a callback when it completes. When this completes its work of trying to add this to the database, there will be a callback. It will return an error object with some information in there, as well as it will return us a copy of the chatline, the new chatline record over here, like this, with the two properties. So what we can do is we can say something like console.log error was, sorry, not getting ahead of myself. It will be null, but yes, error was that, and then console, I mean, I could have done it as one-liner. And then what we'll do is we'll just put in the chatline record as a separate thing over here. Boom, 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 boom. Okay, I think we can go and run this. So flipping back over here, what I want to do is call Node.DB test. We're going to hit this. Note, we will get one deprecation warning, but otherwise I think everything will work. Hey, lovely. So let's see what happens. So we get this big deprecation warning, which we'll deal with in a second to get rid of it because it's ugly. But the actual stuff that ran was over here. Error was, right? Error was null. We didn't have an error. It just came back null. Perfect. We know everything worked. And then what we're doing is we're printing out what we got from the chat line, which is this JavaScript object. There you go. Username Quill18. The chat line is hello chatting world. And we've got two extra things thrown in here. Now, the _v or double _v over here is related to some schema versioning stuff, which we don't have to worry about right now. At least that's how I understand it. But this part is really important. Every record, every document that gets added to a collection will have this unique identifier for it, which is really important because this is the unambiguous way to refer to this specific document and absolutely no other document in there. We can use it in our code to link one document to another by, having, if we have some sort of code somewhere that's like, I don't know, right? Like rather than storing the username in here, for example, we might have something like user underscore ID. And instead of having the text username, we would actually just have the unique ID that represents this user. In fact, that's much more likely how you would typically organize the code in your database like that, so that you could very easily link back to this proper user that way. Or we might still store the username as well, because it might be handy to have a copy of the username in here, but we would probably just store a reference to the user underscore ID, which is some other document in some other collection, for example. So this is great. The other thing with this ID is it is indexed, which we'll talk about in just a moment. But yeah, so this is a new record that's been added to the database. And what we can do now is we can switch over to Compass and actually take a little peek at that. So over in Compass over here, if I refresh, I will see a new database. There you go. TestDB is a new database over here, and it has a single collection in it called chat lines. And if I click on that, I can see the record in this database. There it is. There's my one record in here. We can do all kinds of things. You can create stuff. You can import new stuff in here. You can modify the indexes. What is an index? So remember how I was saying in the example, we could store, say, all our user information in a single text file that our application constantly writes to and then reads, right? But the problem is if we have a million users, you might have to look through a million lines in this text file to find the one user during their login, which is really slow and inefficient. What indexes do, indexes will index on usually a specific singular piece of data, although it can be multiple pieces of data in a database, and will organize itself internally as probably some sort of binary tree or something like that. The point is, it's very fast to look this up. If we had a million lines of chat in here and we were trying to find a specific one based on this ID, if we didn't have an index, we'd have to look through potentially all million lines in there until we found the one we want. Like if it's the last one in the database, we'd have to look through a million of them. But with the index, it'll happen very quickly. It's actually effectively only going to look at, it's a whole power of two thing and da-da-da-da-da. You know, it's going to be, instead of looking through a million lines, it'll be looking through like 10 lines effectively to find the one in the end. So indexes keep things very, very fast. We can create more indexes. We can create it in here in MongoDB Compass. Absolutely, 100%. Although likely what we're going to want to do is if we want to have indexes, for example, if we want to be able to, in our user name database, right? Like not this chat one, but let's say we have a database of all the users. It will have its own ID. All of our users will have a unique ID, which is going to be very convenient to refer to things at. But when people log in, they don't log in using this weird numeric ID. They're going to want to log in using their username or email, right? So we are going to need an index on their username and email. You know, maybe I like websites that give you the option of doing both, or maybe either. I don't know. I don't know what we're going to use for a login. But you're going to want an index on it because you don't want to look through a million records to find Quill18 somewhere in here because you don't have the numeric ID. We want an index on the username so that we can find Quill18 very quickly and then check to see if their password that they've entered in is correct, Hunter2. So we're going to want those indexes. And again, we can create in here or any of the MongoDB management tools, whether it's the Visual Studio Code plugin or if it's the command plugin and various things. But we'll also be able to do that as part of our configuration over here, which we will look at in the future. But that is something that we're going to do. But for now, hey, we got our database working fine. Now, the neat thing is that it doesn't actually create this stuff until you use it. For example, if I were to double up on this line of code over here, and I call this dummy, like just a dummy test, and like this, right? I'm registering a new model inside of Mongoose called dummy. We'll use the same schema because there's no reason we can't do that. Let's say I run this again. So I'm going to kill this, which is still running. I'm going to run this again. Boom. The reason it's still running is I think because our database connection is still open. So it's in sort of this like idle waiting state over here. There's an internal loop with the database. So we're going to run this a second time. I'm going to go back over to Compass. I'm going to refresh, but there's no collection called dummy. The reason for that is that by default, it doesn't create the collection until you add the first record to it, right? So if I take this whole thing, boop, 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 and now just make one slight little change. Oh, we didn't have our semicolons there, which is fine. Where we create an entry into dummy over here. I'll put a little D at the end of each just to showcase it. And then we run this. So kill this, run this again, go back into Compass, refresh it. Now dummies exist because it didn't exist until we try to add a record to it. Anyway, let's remove this and this, because that's obviously working very well. And now let's go ahead and remove this deprecation warning, because this is obviously very ugly and poopy, and what's the deal for it? So it's talking about we should use unified topology, right? Current server discovery monitoring is deprecated, This is related to, there's various code you can run to try to auto reconnect to a database in your ongoing application. What happens if the connection drops? There was code and things like that in Mongoose that would allow you to do various reconnections and things and whatnot. But right now it's using the old school way of doing it, and we're getting the warning that, hey, you should use the newer code way of doing it, the newer school way of doing it, and we can do that just by setting this. So use unified topology true. And that should get rid of the deprecation warning. And then I'll show you one other thing in a sec here. So if I run this again, whoops, what did I do? Oh, I spelt it wrong. That would certainly make a lot of sense. Okay, let's try it now. Hey, there we go. So now we don't have that deprecation warning. And the thing is, if you are doing a lot of connections, you can do exactly the same thing here. Boop, boop, with use new URL parser. If we do this, I no longer have to specify this little bit over here. Let's try this. Everything should still work the same, and it does. Excellent. And then if we go over to our compass here and refresh and check the chat lines, we have multiple copies of this chat line, all with a different unique ID, because we keep running this and adding that in there. But that is fine and groovy and all good. So what I'm going to do here is I think I'm going to wrap up this episode. So now we have a confirmed test, our database. We can correctly connect to it, and we can create records to it. I mean, there's going to be other things we're going to do. Chatline.find, like find by ID and update, for example, which we could do, but we're not gonna. I'm editing the video, and I went on for like about 10 minutes doing the update and looking at different things and tweaking stuff, and I realized this video's gone on long enough, and we can move the updates to another scope, especially when we go and refactor the code to be for realsies proper, talk to Unity, and also I still want to do that that discussion about coding standards and stuff, and move to different ways of declaring variables. We're going to wrap it up here, though. Thanks a lot for watching. This episode is brought to you by the incredibly awesome and incredibly patient people who support me over at patreon.com/Quilly18Creates. And that includes our mic check supporters. We got David Crew, Ilunda, Julian Gallic, Thomas, Jeff Fellows, Tiburon, Pavel Zdanov, Michael McClintock, and Steven Stager. Again, thank you very much for your patience in finally getting this thing out, and I hope you guys do make it to the London Dare streams as well when they happen. The last one was pretty epic. Still working on the post-mortem for that. Stay tuned.